Hi, this is Miss Johnson. This is the 1-3B video notes, so vertical and horizontal dilations of stretches and compressions. Dilations is something where the shape is changed in terms of wideness or thinness. It's not moved around the graph. So just a reminder, our basic formula is that we have uh, A, when A is greater than 1, it's called a vertical stretch. So we're just talking about this A here. When A is between 0 and 1, in other words, a fraction or a decimal, it is a vertical compression. When B, which is in front of the X, is bigger than 1, it's a vertical compression. If B is a fraction or a decimal, it is a horizontal compression. If the negative in front of the B, if there's a negative in front of the B, then that flips it across the y-axis, sort of like turning your hand over when you're waving. When it is reflected across the X, it's like you're flipping your hand over horizontally. And then we already talked about translations to the left, to the right, up, and down. So today we're just going to focus on the vertical stretch and vertical compression, and horizontal stretch. Okay. So making the stretches and compressions and reflections work for you. If we have 4x squared, this is going to be we want to figure out first what is its parent function. Well, if we take the numbers off, what's left behind is x squared. So that is our parent function. Then we want to look at any vertical dilation. This is any number in front of the parentheses. In this case, it's a stretch because our A value, 4, is bigger than 4. So that's when it is squeezing or pulling closer. It's going to squeeze towards the y-axis, which almost looks like it's being pulled like a rubber band being stretched from north to south, okay? So for any parent function, when A is between 0 and 1, the graph will compress or push toward the x-axis and widen. When A is greater than 1, the graph will stretch or pull towards the y-axis and grow slimmer. So let's see how that would look. So we started out with A times x squared. As you see, A is getting between 1 and 50. So it is going, that's at 1, it is the parent function. At 50, it was just widening it out. It was pulling in towards the x-axis or the y-axis. So now it's going to show from 0 to 1, where A is a fraction. And now it's widening and it's pushing down towards the x-axis. Okay, so let's do some your turns. Does the transformation f of x translating to 9 times f of x, what does that do to the graph? So does it stretch it vertically? Does it stretch it horizontally? Does it stretch it shrink it horizontally, or stretch it horizontally, or shrink vertically? Stretching means that it is pulling towards the x. Vertically means it's pulling towards the y-axis. Shrinking towards the horizontal means it's pushing towards the horizontal axis. Shrinking vertically means it's going towards the x-axis. So which one is this one? If you chose that it is stretching vertically because it's pulling up towards, and its A is positive, so that's a stretch. Shrinking is another way of saying compressing. So basically shrinking horizontally, shrinking vertically, or stretching vertically is what they're asking. What does transformation of f of x going to 1/4 of f of x do? If you chose that it is shrinking vertically, or in other words, compressing vertically, then you are correct. Okay, so for horizontal dilations, for any value of b between 0 and 1, the graph will stretch, pull towards the y-axis. So now, and if it's greater than 1, it will pull away from the y-axis will push towards the x-axis. So you're seeing that it's getting bigger because y is between 1 and, or b is between 1 and 50, and this is the x cube cube root function. And now we're going to change it so that it is between 0 and 1, in other words, a fraction or a decimal. And this is going to be a horizontal stretch. And notice it's squeezing closer and closer to that x-axis. Okay? So for your turn assignment problems, what does the transformation of f of x when it's changed to f of 7 times x do to the chart? Does it shrink horizontally, shrink vertically, stretch vertically, or stretch horizontally? If you chose that it shrinks horizontally, in other words, it compresses horizontally, then you would be correct. On transformation of 1/7 x, going to 1/7 of x, what does that do? If you said that it stretches horizontally, you'd be correct. So it's really important to understand that when numbers go inside the parentheses, we have to think backwards to what it is if they're outside the parenthesis. Okay, so making the stretches comparison work for you, here's another version of it. We have 2x, 2 parenthesis 2x squared. So what is our parent function? Well, again, if we take out the number in front of the x, we get x squared. And so we have our parent function. If we apply the horizontal compression, because 2 is bigger than 1, it's a compression because it's inside the parentheses with x, horizontal compression, then it stretches by a factor of 1/2. Now, the reason it's written like this is because that is how you'll have to report it in school in HRW. When you're squeezing by or compressing by, if it's a horizontal situation, we have to flip our numbers. So even though it says 2 inside the equation, we factor by the flip of that, which in this case is 1/2. So it is going to push towards the y-axis away from the x-axis. Okay? So stretch and comparison recap. A times f of x, where a is greater than 1, is a vertical stretch by a factor of a, exactly what it says in front of the f of x. A times f of x, when a is less than 1, is a vertical compression by a factor of a. So that's how you would write out your answer. F of b times x, when b is greater than 1, it's a vertical compression by the flip of whatever's inside, 1 divided by b. If b is 1/2, then 1 divided by 1/2 is what your factor would be equal to 2. So whatever b is, flip it upside down when you're doing horizontal. When b is less than 1, then it again is a factor of 1 divided by b. So again, for horizontal only, when we record the factor amount, take your horizontal compression, whatever's in front of that x in the equation, flip it upside down when you report the factor amount. Okay? So it is the inverse of that. So you must remember this. Here's something very interesting to understand. A vertical stretch is the same thing as a horizontal compression. They will result in the same graph. A vertical compression is the same thing as a horizontal stretch. They will result in the same graph. Okay, so that is all of the vertical stretch, vertical compression, horizontal stretch information.